Hello and welcome. In this session, we are going to learn how to migrate PostgreSQL, which is running on-premises to AWS RDS. So these are the steps which we are going to follow. So we are going to do the migration of on-premises PostgreSQL server to AWS RDS to the PostgreSQL. So I have a setup already established wherein I have a source setup wherein we will log in through the pgadmin tool and it is already running on Linux server. On the target side, we are going to create an RDS and we will try to connect it using the pgadmin tool. So there are a few things which I have already performed for PostgreSQL on the source side. So what I have done is on the source side, I have installed PostgreSQL 12, so using yum install, and this is the link. Then I have followed yum install Postgres SQL 12, then Postgres server, and then finally I have initialized the database, enabled PostgreSQL 12, started it, and now we are going to follow from here. So for the source environment, I'm already logged in using the MOBA Xterm. So let me show you that. So this is systemctl status postgre 12, so you can see that it is running. And on the source side, since this is our demo environment, we need to ensure that firewall and SE Linux, they should be in an appropriate way. So our firewall should be in the state of stopped. So I have stopped the firewall. You can see it is in the stopped status, and we will check the status of SE Linux as well. So this should be disabled, otherwise we will go into issues. So this is disabled. This is my source setup, and you and the default PostgreSQL user, we will give some password. So I have already changed the password of default Postgre user on the source side. So I have mentioned alter user Postgre password and given the password. And before we do anything, let's go and create the target environment, and then we will start from this step which says enable remote access of PostgreSQL 12, because by default Postgre doesn't allow the remote connection. So we need to make some changes which are already made. So I'll just explain what has been done so as your Postgre can enable the remote connection. So we'll go to the AWS RDS. I have already connected to AWS console, and we are going to create a database. So we'll say create database. You need to have the login details so that you can create it. So I'm going to create a Postgre database. So this session will also show you how you can connect to your Postgre RDS remotely. So there are few things which we are going to perform. So here is the version. So my requirement is if you see the versions which are available, it is starting from 9.6 and it is ending at Postgre 13, which is the last available public release version. So you can see that it is available, and we wanted to take a lightweight machine, so we'll say just dev and test environment. In the settings side, we have to mention the database name, so we'll say RDS Postgre demo, and this is the master username, which is uh, Postgre. So we'll give the password, fill in the password again. I have kept the password simple, and we will choose the lightest weight machine. I have chosen 2 virtual CPUs and 8 GB of RAM, and 20 GB maximum storage, which I'm going to use. I'm not going to enable storage auto scaling. We are not going to create a standby instance. And from the connectivity side, we'll go with the default VPC, which is not recommended in production environment. Since this is a demo, so we are going with the default VPC, and we will try to access it publicly. The endpoints will be accessible from outside. So that's not a good thing, but just for this demo we are doing it. And in the additional information we don't have anything, so we are taking the default port, which is 5432. We have different types of database authentication, but we are going with the password authentication. But if you want, you can have one more layer of authentication, and you can enable the IAM authentication as well. If you have Kerberos, you can go with that also. In additional configuration, we are not going to give anything else that can be changed later on. So we are saying create database. So this is going to create the database. So once it is created, this is going to take 2 to 3 minutes. So once it is done, we have to check the remote connectivity. Since this is a RDS environment, so SSH is by default disabled. So you can connect through uh, the endpoint and the port with the relevant tool. In this our case, we will try to log in through PSQL or pgadmin tool. So this is going to take few minutes. In the meantime, we will come back to our step-by-step migration. And on the source side, we were discussing like we have changed the Postgre user uh, password to some password which we have given. Then we are going on the source side. It's all about the source side. On the source side, we have to enable remote connection so that other than localhost, somebody else can also connect. It is all about the application also. So on the source side, we will check the postgresql.conf file. So I'm logged in as Postgre user. Postgre is the database. Postgre is the OS user, and Postgre is a database also, and Postgre is the database also. So just be sure that you know all the three. So what we are going to do is we are going to check the postgresql.conf file, and we are going to check what is the listen address. So if you see the listen address, by default it will be localhost. So you need to mention the IP address of the host where your server is running, PostgreSQL server is running. Otherwise, it is not going to be accessed from outside. The next thing which we need to do is we have something called as pg_hba.conf, which is Postgre host based authentication. In this file, we need to add one line which will allow the application IPs or the set of IP address to connect to your source database using the password algorithm. So this is required, otherwise it is not going to be accessed. So these two changes are mandatory. You need to make it out. The next thing, and which IP address has to be feed in here. So it is the range of the IP address of your organization or your environment wherein you are working. And once these are done, you have to restart your PostgreSQL server just to ensure that all the changes are effective. So we are going to restart it, and we will check the status. So you can see that it is running, and these are the background processes which are running. Now we will try, if everything is fine, we should be able to connect. So what is the default way of connecting? You say PSQL, and you will be able to log in. But in case you wanted to get password authentication used, you have to mention this. So it is psql-u, which is the username, -h is the host name, and just press enter and feed in the password. So this is how you log in. The next thing which we are going to do is we are going to take a backup of all the databases on the source side. So we have a directory which is already created. So we are going to take a backup of all the databases over here. So before we go from here, we talk about the migration strategy in relational databases system, or let's say PostgreSQL. So there are two type of migration strategy. One is online and other is offline. In online migration process, what happens? Your source database will keep on running and you have to transfer the data to your target environment, which is RDS, and your changes will keep on happening in the source environment because the application is still live on source, and whatever changes are happening, you have to capture that and you have to keep transferring them to the target side. This is one of the most difficult situation because your application do not afford to have downtime. So what you need to do is you need to have a mechanism in place so that your you can take a you can create a replica on the target side in RDS, and your changes whatever are happening on the source side, they will keep on replicating. So there is something called as DMS, Database Migration Services, which is provided by AWS. So you can use that service. So what that service will do, it will get the connection from your source database. You will have an admin user, you will have the source IP of the server, the user, which will be the admin user, and using the credential, it will connect to the source environment, and it will connect to the target environment as well, which is your RDS, which is getting created. Once the connection is made, what it will do is it takes a backup of your source environment in one shot and it will restore it over there. So there are a couple of types of migrations which are inbuilt in DMS. One is what it will say is one time. So we just take a backup and restore it over there. And another is keep replicating. That means whatever changes are happening. So that is known as change data capture. So whatever changes are happening, keep on transferring those changes from your source to the RDS. So that's also available. And the third one is both. Take one time and whatever changes are happening, keep on doing all those. So that is only that is good when you have an online application and they cannot afford to have downtime for this migration purpose. But in our case, since it is a small database, we are going to take a backup. So what this cloud provider suggests is if you can afford a downtime, you go with your native tool like pgdump or pgdump all. So you can take a backup and you restore it using the relevant tools in the target side. So the APIs are already exposed, so you can directly import into your target environment. The only challenge in the target environment is you cannot access the operating system. So either you have to use an intermediate operating system on your AWS side, you create an EC2 instance, and from there you dump all the backups and you execute PSQL from there, and you can do everything from there. And what is the most time consuming task will be when you take a backup, you transfer it to the EC2 instance, and from there when you restore it to the target site. Those are the time consuming activities. So you have to plan it in a such a way that whatever downtime is approved after the POC, you can perform it in that duration. So that's all about the migration strategies. In our case, we are going to take a backup and we are going to restore it. So we are going to find the size of the database. So what I have done is I have created, okay, it's all gone, or okay, you can see I have almost 100 database, and this is DVD rental database, and the size of each database is 15 MB. That means almost 1500 gigabytes megabyte of data is there. So it is just 1.5 GB. So it is roughly 1.6 GB, and there are 100 tables, so I assume this will be closer to 1.5 gigabyte. What you can do, you can list down the database name using like this, also using the catalog table. Or additionally, if you wanted to see the list of the schemas or the namespaces, you can do this. These are the things which you need to do in advance just to capture the informations. And you can list down the different types of objects which are available that will help when you perform the migration. This is the post migration things which you validate. And you can list down the users which are on the source side, just to ensure that those users should be available on the target once the migration is completed. In our case, this is just one user, but you can create many and then you can see whether it is working or not. You can check out the list of the extensions which are installed, and you have to verify whether everything is available over there or not. So there is a lot of restriction in RDS for PostgreSQL, so you need to ensure that your application continue to work when you migrate to RDS. Now in the migration phase, we are going with the offline migration. We are not going with the online migration, which is DMS. So what I'm going to do is we are going to take a backup of all the databases on the source side. Let me see if the target is created or not. It is created. Okay, let's initiate a backup. So this is started, and what we will do is we will check the security just to ensure that it has proper security group for incoming and outgoing rules. So it is getting opened. We'll see the details. I have enabled the public connection just for this demo purpose. Inbound rule, just added the inbound rule just to see what's there. I'm not going to save anything. So it is just we have selected PostgreSQL and 5432, and this should be the public IP from where I will be connecting temporarily. Okay, the backup is done. We will see it. It's very small backup, roughly some 350 MB or something like that. So what we are going to do now is we will try to connect to the target environment. So how we are going to connect to the target environment? Let's pick out the details of the RDS. We need the endpoint just to ensure that we have the correct endpoint, user ID and the password, because we just enabled the password authentication. There are three types, but we are going with one only. Sometimes it is very slow. Just go to the dashboard and pick out the database. So this is the DB identifier, and we will see what is the um, where is it? This is the endpoint. So we are going to connect it through this. I will note it down over here so that we can test how it is, how it works. On the source side, I have a connectivity with the AWS RDS, or it has an internet connectivity as well. So we are going to test whether from the source side we are able to connect to the RDS or not. You can see we are able to connect to the target side from the source. And how do we identify? You can see the Postgre user, the RDS admin, which is the database available only on the RDS. So we are connected to the target side. Now what we will do is we will connect using the PG admin as well. So we'll create the server. We'll have to mention the um, endpoint. So this is the endpoint. In the connection, we will mention the endpoint. Just feed in the password, and if everything is fine, it should be able to connect. So you can see we are able to connect. So let me delete unnecessary connection. So I have deleted it, and this is my new RDS instance which is created. This is my Postgre default database which is created, and this is the RDS admin which is created by the RDS, and you can see you cannot access it. These are the restrictions which are imposed. So what we will do is the next step which we are going to, so we have everything done. Now we are going to import all the databases. So let's create the blank databases in case if it is required. Or let's go and fire the import. How we are going to fire the import? This is the commands. The only challenge will be, so I have mentioned psql-u username, which is the admin user -h. This is the target username, target database, which is RDS, then -w, which is the prompt for the password, and then press enter. And I have to find out a way wherein I don't need to give the password. So the first one it gave error is for the Postgre database, which already exists. So it is not going to recreate that, and it has started the import. I'm just feeding in the password because for every database it is prompting, but I'll find out a way. Okay, I'm not going to do it for the entire 100 databases. We are just, so every time I have to supply the password, otherwise I can put it in the password file. But let's quickly check out how many databases are imported. So you can see DVD rental is imported, DVD rental _1, DVD rental _10. So this way it is going to import all the databases one by one. And what we need to check finally is the list of the things which we have done earlier, like what are the namespaces that are required, what is the database size which is imported, and the list of the users on the source side and the target side. You need to compare all of them. So just in a nutshell, what we have done is we have an on-premises source database which is on Linux. It is installed with Postgre 12, and we have a target which we created RDS Postgre 13, and we enabled the public access, otherwise that was not required in real environment. And then we had taken a backup of the source databases using pgdump all, and once we have the connectivity established, we imported it. I can continue the backup, but it is going to take a lot of time. So this will skip. So I'll feed the password with copy and paste. I should have dropped the databases which are which I'm going to import it again. Otherwise, it is going to give me this kind of error wherein it is going to check each row one by one. Not a good way. So you have similar feature in DMS also when your application breaks. So what you can do is you can drop all the databases and then you can uh, initiate it once again. This might be slower because the data is going over the internet. If I would have used an EC2 instance in the same zone, then the import would have been faster because it will be in the same environment. Here we have an connectivity between source to target over the internet. We'll try to import some 10 or 12 databases and then we will stop. The main challenge during such kind of migration is the downtime. What is the downtime which is approved? What is the size of the database? And whether the application is so critical that it cannot assume the or it cannot go for the downtime. So everything has to be considered before you migrate the database to the cloud. So that's one of the limitation when we go to the cloud. The size of the database always play a big role, and you have to make your strategies accordingly so as to make sure that your database is migrated within an established time. So DVD rental 20 database is migrated. This DVD rental 22, 23, 24, and at the 25 I'll close it. Okay, let us cross check how many databases we have imported so far. You can see there are 25 databases which are imported. Not all the databases are user databases. There are few which are system databases. The system database, these are the two templates, template 1, template 0. This is the database of RDS, and this is the Postgre default database which is created during the installation of Postgre. And by default here it is also available in RDS. And rest of the things which you need to check whether the users are imported or not. If the users are not imported, then you have to take a script from the source side and you have to import it on the target side. I hope this is going to helpful because we have done so. What AWS also suggesting is you use your native tools for Postgre. You have pgdump and pgdump all, which are good utility. You can use it according to your environment, and the migration should be successful.